Namaste. Welcome to Indian Knowledge Systems Primer Course for Children offered by Anaadi Foundation. In this Bharatiya Ganita lecture, we will look at Pratyayas in Chandas. An introduction to Chanda Shastra. Chanda Shastra was composed by Pingala Naga around 3rd century BCE. The word Chandas means prosody or the science of meters. In his Chanda Shastra, Pingala introduces some combinatorial tools called Pratyayas, which can be employed to study the various possible meters in Sanskrit prosody. The algorithms presented by him form the earliest examples of the use of recursion in Indian mathematics. As Indic scholars have pointed out, Pingalacharya deserves to be credited with the following breakthroughs. First, the origin of binary arithmetic. Second, the combinatorial techniques. Third, the Meru Prastara or the so-called Pascal's triangle. And finally, the binomial coefficients and also the so-called Fibonacci sequence. Pingala systematically studied the mathematics of poetry and arrived at the breakthroughs we mentioned earlier. Now, what are the contents of this Chanda Shastra, which is one of the earliest texts to systematize this study? The text Chanda Shastra consists of 308 sutras spread across 8 chapters in all. Except for the first and the last chapters, the rest of the text presents an exhaustive account of different meters in Sanskrit. In chapter 8 of Chanda Shastra, Pingala introduces the following 6 pratyayas or combinatorial tools using which one can compose. The first is prastara, a procedure by which all the possible metrical patterns with a given number of syllables are laid out sequentially as an array. The second is sankhya, the process of finding the total number of metrical patterns or rows in a prastara. The third is nashta, the process of finding for any row with a given number the corresponding metrical pattern in the prastara. Next is uddishta, or the process of finding for any given metrical pattern the corresponding row number in the prastara. Laghakriya. Laghakriya is the process of finding the number of metrical forms with a given number of laghus or gurus. Patterns with syllables. In Sanskrit poetry, composers picked a meter and composed in it. Let us try to understand what a meter is. If we are given 2 digits 4 and 5 and we are asked to form all possible 2-digit numbers with these, what do we get? We get 4-4, 4-5, 5-4 and 5-5 as all possibilities. Similarly, if we were asked to form a 3-digit number, what would we get? We would get 444, 445, 454, 455, 544, 545, 554 and 555 as the 8 possibilities. Mathematically, the answer would be 2 raised to the power 2 possibilities and 2 raised to the power 3 possibilities. Similarly, if we were to form a 2-syllable pattern with a guru and laghu sound, the possibilities are guru guru, guru laghu, laghu guru and guru guru. If we are asked to form a 3-syllable pattern, what would the possibilities be? It would be guru guru guru, guru guru laghu, guru laghu guru, guru laghu laghu, laghu guru guru, laghu guru laghu, laghu laghu guru and laghu 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 as the 8 possibilities. Similarly, poets would choose a meter with n number of syllables in them. That is how we come up with different and so many possible combinations. Mathematically, these combinations would precisely be of the value 2 raised to the power n. Now, these combinations is what Pingala's algorithm for prastara helps us do. Prastara is an ordered listing of all possible combinations. Pingalacharya presents the steps for constructing the Prastara in 4 terse sutras in the Chandas. The procedure outlined here helps in an ordered and consistent listing of all possible combinations of an n-syllabled metrical pattern, which is technically termed as a Varnavritta. The creation of this ordered list will help everyone be on the same page and be able to communicate better. It is important to keep in mind that this construction is for Varnavritta or metrical meters based on the length of the syllable. Let us directly now discuss the method encoded in the sutras. Understanding Prastara. We saw that we can create many patterns using numbers or using just Laghu and Guru for any number of syllables. How do we now list all possible combinations for a 2-syllable or a 3-syllable meter? How do we find them for 5, 6 or 7-syllable meters as well? Pingalacharya's algorithm or procedure called Prastara allows us to create all possible metrical patterns for a given number of syllables. Let us now dig into the meaning of this very terse verse, which thanks to the work of several Indian scholars we are able to understand. So, Pingalacharya's algorithm for Prastara gives us these following steps. First, form a Guru Laghu pair. Write them down one below the other. Insert on the right Gurus in one pair and Laghus in another. Repeating the process, we will have 8 metric forms in the 3-syllable Prastara. Let us see how this goes. On the left here, you can see we have written down Guru on the top and Laghu right below it. Now, how many ways can we form the 1-syllable sound? The answer is 2, because how we can find the total number of combinations as 2 raised to the power 1, which equals 2, since the sound can either be Guru or Laghu. But in the case of a 2-syllable metrical pattern, it looks something different. To get the correct ordered list, Pingalacharya says copy the previous pattern twice as 2 sets. So, we have Guru Laghu and right below it we place another Guru Laghu. Add Guru to one set and Laghu to another. So, to one set here we have added Guru Guru and to the bottom set we have added Laghu Laghu. Then we get the total number of combinations, which is 2 raised to the power 2 equals 4. What are these 4 combinations? They are Guru Guru, we read them this way: Guru Guru, Laghu Guru, Guru Laghu and Laghu Laghu. Now, let us try the same thing for a 3-syllable metrical pattern. We already have this pattern in place. To get the correct ordered list, Pingalacharya says that copy the previous pattern twice as 2 sets. So, we will copy all the 4 sets which were available to us again here at the bottom. Add Guru to one set and Laghu to another. This will give us the total number of combinations, which is 2 raised to the power 3, 8. Similarly, if we keep doing this process, we get the patterns for further meters with 4-syllable and 5-syllable and so on. Now, moving on to Nashta. Let us say we list and order all possibilities of a 6-syllable meter. How many possibilities will be there? Like we learnt before, the answer will be 2 raised to the power 6 possibilities will be available to us. Now, these will be 64 in total. However, if someone were to ask you what is the 42nd pattern, right? How would we list these without taking the strenuous task of writing all of these down? So, to do this quickly, Pingala has given us an algorithm, a way called the Nashta procedure, which will directly give us the 42nd pattern in the sequence. The steps presented here in these 2 sutras imply essentially the following. To find the metric pattern in a row of the Prastara, start with the row number. Halve that number if possible and write a Laghu. If it cannot be halved perfectly, add 1 to the number and then half that value and write a guru. Repeat the above 2 steps till all the syllables of the meter are found. To begin applying the algorithm, let's try and recollect the rules. So, our rules are that if our number is fully divisible by 2, we perform the number divided by 2 and mark a laghu. If however, the number is not fully divisible by 2, we add 1 divided by 2 and mark a guru. So, 21 plus 1, 22 divided by 2 gives us 11 and we mark a guru. 11 again is not divisible by 2, so we perform 11 plus 1, 12 divided by 2 and mark a guru. Our result from the previous calculation, 6 is divisible by 2, so 6 divided by 2 we write and mark a laghu. 3 is not divisible by 2, so we perform 3 plus 1, 4 and divided by 2 marking a guru again. Finally, we get 2 as an answer which is fully divisible by 2, so 2 divided by 2 marking a laghu, and this is where we come to the end of our calculation. So, the 42nd metrical form in the prastara of a 6-syllable meter is laghu guru guru laghu guru laghu. Pingala's algorithm for Udishta. If some 6-syllable pattern like laghu guru laghu laghu guru laghu is given to us and we are asked to find which number in the sequence will this pattern come in the ordered list of all possibilities, we can use the Uddishta procedure. The steps presented here in these 2 sutras imply essentially the following. We will start our calculations with the number 1. Now, whatever pattern is given to us of laghu guru, we will start scanning the pattern from the rightmost end, beginning with the first laghu from the right. Double it when a laghu is encountered. Double and reduce by 1 when a guru is encountered. Repeat the above 2 steps till all the syllables of the meter are found. Now, let us try and apply this method to an example. To illustrate, we shall consider the following example. We will apply the Udishta algorithm to find the row number of the metrical form guru laghu laghu guru in the prastara of a 4-syllabled meter. We start with 1 and scan from the right. Since the rightmost pattern that we encounter is a guru, we skip it till we encounter our first laghu. In the next syllable, when we scan from the right, is laghu, so we get 1 into 2 equaling 2. Since if you remember the rule, whenever we encounter a laghu, we must double it. The next is also a laghu, and so we get 2 into 2, we double the laghu giving us 4. Finally, we have guru in the sequence, and as we remember from the rule, whenever we encounter the guru, we multiply it by 2 and subtract 1 from it. Hence, here we will do 4 multiplied by 2 minus 1 giving us 7. Hence, the combination guru laghu laghu guru in the ordered list of a 4-syllable meter would be the 7th metrical form in the prastara. Try out the Udishta algorithm to find the row number of the following metrical forms on the screen. I hope that the procedure is clear to you and you can have some fun trying to find what row number these fall into. In today's lecture, we saw how Pingalacharya not only listed different meters, but in fact went deeply inquiring into their very nature. So much so that, like you saw in some of the procedures we applied today, if someone gives you an nth combination, you are able to find where in the ordered list that would fall, or you are able to still calculate what a 1/32 or a 100th pattern in a particular meter system would look like. These are equivalent to what we learn in the field of computer science and in the world of binary numbers even today. And it is amazing to realize that Pingalacharya did this as far back as 300 BCE. I hope that this particular lecture or Chanda Shastra was not only interesting and exciting but also inspirational for you, and I hope that you will keep learning Bharatiya Ganita as we go.